In this video, we will learn about some of the very important machine learning concepts. The several components in the for learning, this is set of input variables and set of output variables. In the aspect of machine learning, statistics and pattern recognition, the inputs are mentioned with different terminologies, though they mean the same, like predictors or independent variables or features. They mean the same and they mean the input variables for the machine learning. And then the set of output variables, also known as responses or dependent variable. Y is equal to ax1 plus ax2 plus ax3. So y is dependent on x1, x2, x3. So here the input is x1, x2, x3. So x1, x2, x3 are independent variables or predictors or features. And y is the response or the dependent variable, or also called an output. The type of features can be categorical, quantitative, numerical, which is and also can be factors. There is a supervised type of learning where, based on the set of feature and the predicted variables, the outcome variable is also known, and that guides the whole learning process. This learning process is also called training process. And the output can be a quantitative or a categorical. For example, if we know the features, then a certain set of features make one category, say A. Another set of features make another category, B. And A and B are called classes or groups. In another example, a set of features gives an output which is numerical or quantitative in nature, 24.5. Another set of features gives an output of 115.6. So these outputs are numerical in nature and it is called quantitative. So let us see some examples later for these supervised learning. Two types of tasks can be accomplished using the supervised type of machine learning. One is called regression, where we predict a quantitative output. Another task is classification, where we predict qualitative output. If we see the classes are 0 and 1, so there may be a confusion. 0, 1 is quantitative, correct? But we can also say it is categorical because there is a binary class, 0 and 1, or -1 or 1. There can be more than two classes, 0, 1, 2, A, B, C. So the output, if it is quantitative, we say it is regression task, and otherwise categorical, it is called classification task. When we are predicting a return for a particular stock prices, so then stock prices will be predicted in dollar or rupees or any currency, and the value will be numeric. Whereas in the classification, if you see here, bull and a bear, so there are two classes, which is categorical. The objective too is learning from the data, where unsupervised learning is there. So that means, given a set of input features, the output is not known. We are only given the input data, and the algorithm for unsupervised learning tries to cluster or organize the data, input data, into groups. So this is also called clustering, which is unsupervised, and there won't be any outcome variable as we have seen in the supervised. For example, if you see here, there are two algorithms and more algorithms like k-means, hierarchical clustering, density based clustering. There are many algorithms. So in this clustering, In the first case, in the left hand side, if all the circles are black in color, then depending on the distance measure, we can say that the left hand side is one cluster, right hand side is one cluster, and then the center is another cluster, and we can color them red, brown and green. So initially we don't know the leftmost is in which cluster, 1, 2 or 3. The algorithm, using the distance measure, tries to form a group. In the example below, if there is an input with different types of balls. Seeing the pattern of all the balls using color, texture, shape, design or patterns, the algorithm understands that there are 3 types of classes or 3 types of clusters which can be formed. So it doesn't label basically A, B, C like in the supervised. It just gives you 3 clusters: cluster 1, cluster 2, cluster 3. So these are some of the ML tasks in the real life. For example, classification of a mail, whether it's a spam mail or not spam mail. Then object detection, where you are classifying the classification where it is a face. Then from the picture for vehicles, it is detecting which it is a car, which vehicle it is. So you can train the images and say this is this type of model of car, or this is a truck. So this is supervised. Similarly, for spam mails also, we can train some of the spam and tell that these are the spam mails and these are not spam mails. So after training, we can test it with the new data. Then news articles, we can classify them by seeing the content, whether it is a food article, sports article or related to politics. And there's a weather forecast where we can train, and again we can say it in the classes as this cloudy or sunny. Coming to one of the regression tasks, which is real life example, where we can predict the gold or the stock prices by seeing the historical data and try to regress from the previous input data or from the past data. Coming to the another right hand side, this is a clustering, which is the unsupervised way of learning. We are given pictures, images. It finds that it has 3 patterns. One is the blue color predominant with clouds, and there is sunset, and another is the natural scene with the green and the blue mix, where it is most of them are having greenery. Then there is a collaborative filtering, where we have the recommendation engine, and depending on the client's previous judgments, we can recommend him like Netflix recommendation or book search recommendation to the community of the users. Then ranking or comparing the items, find similar images. So this type of an image retrieval, where you can rank and use the intelligence by understanding the similarity between the images. This is quiz, where you can say which of them is a categorical output. This is the answer. Special mention of ordered categorical, where the categories are ordered like small, medium, large. But if we say dog and a cat, it is not ordered. I don't give importance to dog as compared to cat, or cat as compared to dog. So they are not ordered categorical. Small, medium, large or grades A, B, C, they are called ordered categorical. Mathematical definition for the learning task: input variable as x, which is a vector because they consist of features, and the quantitative outputs denoted by capital Y. Qualitative outputs like the classes are denoted by the capital G. So given the value of the input x, vector x, we need to predict the output, which is called y cap. The real one is y, the actual one is y, and when the model tries to predict, we say it is y cap. So expectation of the model y cap output is that it should be equal to y. So the prediction should be equal to that of the actual. If there is a gap, if there is some difference, that is considered as an error, and then again the machine is learned to adapt this or to minimize this error. This is the predictive modeling. That means this, what is this model? Model is nothing but it is trying to learn a target function which best maps the input variables to an output variable y. So y is equal to f of x. So this model is nothing but f, which takes the input and gives the y output. But when you are using this as a model, then it becomes y cap or y hat. Training data, where you are having the input as well as the output. The mapping is already known, and the training consists of the algorithm which tries to create this function, which as rightly mentioned here, learning the function that maps the input variable to the output variable. Taking an example of the supervised domain, this is a supervised learning where the feature matrix is there. These are the features, age, size, and the output is the last column, which is the target, that is the outcome, whether it is malignant or not. So it is binary class, 0 or 1. So given a function taking the input feature vector tries to predict the output target outcome. If this target matches, output matches that of the actual one, that means the prediction is correct. Let us now discuss the integral aspects of the ML model training. What are the aspects which we should take care while training model, and how much should be the data, how much should be the samples, and what are the problems or challenges we face during the model training. There are two types of algorithms, parametric algorithms and non-parametric algorithms. The parametric algorithms, the function, it already knows the distribution of the data. Example are linear regression, logistic regression algorithms, and they have high bias, which makes them fast to learn. The bias is high because already the distribution of the data is known, and it is generally very less flexible. They have lower predictive performance on complex problems because the flexibility is less. In non-parametric algorithms, they do not have any strong assumptions about the form of mapping, and thus is free to learn any functional form from the training data. So basically the non-linearity can be easily learned because it can explore more, and they have a high variance but a low bias. So it's flexible but achieves better accuracy when large amount of input data is given, and it requires lot more data and more training time. It works very good for the complex problems. This is a very important concept, as we were talking. High bias in the parametric, high variance in the non-parametric algorithms. The goal is of any model, it should to learn perfectly, it should have a low bias and low variance. It's a bit difficult to achieve. So for the sampling of the data, two statistical concepts are very important. One is the central limit theorem, and another is the law of large numbers. Let us see what does it mean. The central limit theorem, it emphasizes that if the sample size n grows, the distribution becomes more like a normal distribution of the entire population, with the mean of the sample nearly equal to that of the population. And the standard error, which is the standard deviation, approaches the standard deviation of the population. So if the mean and the standard deviation of the sample matches that of the population, it means the data which has been taken for the sample is almost a correct representation of the population, and hence we will be having low bias and the low variance if it is a true representation. This is the Gaussian, which is the normal distribution. It's a bell-shaped curve with mean, if you see, it's a 0, and then there is a standard deviation of 1 which comprises of the 68% of data, standard deviation of 2 comprises of 95% of data, and standard deviation of 3 comprises of 99.7% of the data. The data lying outside the plus minus of the 3 standard deviation determines the outliers of the data. This is an example of IQ value where the 130 IQ is considered to be 2 standard deviations above the mean, which is genius. 70 IQ is 2 standard deviations below the mean and is considered as a cause of concern of mental retardation. So thus we can see the numerical values play a very important role in this Gaussian normal distribution to understand how much the data is deviated from the average or the mean, and we can get some insights of the outliers as well. Another very important aspect is the law of large numbers. As the size of sample is increased, more accurate estimate the sample mean will that of the population mean. So collecting more data is helpful, but we have to consider that the data is relevant data and is not a noise data. If we collect a lot of irrelevant data, which is also called a noise data, then it won't be helpful in representing the actual population. So what is the difference? In the central limit theorem, it does not state anything about a single sample mean. Instead, it is in a broader sense states something about the shape or the distribution of the sample means. So what is the implication of law of large numbers in ML? Considering the training data must be representative of observations of the domain. The test data, given the training set data, must also be given the test data set. Test data set is actually never seen by the model. It is not the part of data on which the training is done. So usually the 80-20 split ratio is used for training and the test data. There is also called a validation data, which is a part of training, but while training the model learns by using the validation data, and then this type of cross validation is also used so that the bias is reduced and the training is done on different sets of sample data. Then model skill evaluation is developing a multiple independent evaluations of the given model such that the mean reported skill from the sample is an accurate estimate of the population mean. Very important aspect of this bias variance trade-off, whether the model should have a high bias or a high variance, and though it is expected both should be low, but it is difficult to achieve the low for both the bias and variance. So when we are having a high bias or a high variance, then there are chances of overfitting or underfitting. So we'll understand this by what do you mean by overfitting and what do you mean by underfitting. Overfitting is a high variance which leads to more bad than good, and underfitting is a high bias. So that means we are not able to fit more data by the model because we are very much biased. So a model that generalizes well is neither an underfit nor an overfit. This is a visualization of underfitting, overfitting. If you see, this is too simple to explain the variance. So it is not, this line is not able to segregate the cross and the circle properly. Some of the crosses are considered to be a part of the circle. So this is not a correct representation of the model has not learned properly. It's underfitting. In that overfitting, curve is able to learn properly, but it is a very complex curve. A very complex curve to reach to this function f of x is very difficult. The appropriate fitting is this one, where it may have an error of 2 crosses, but this is a simpler curve which is more accurate. Now coming to this right hand side figure, we can see how this overfitting is related to the variance and bias. The bias is high and the the bias is low for overfitting and variance is high. Whereas for underfitting, the bias is high whereas variance is low. So these plus, which is the black color, are called the data points. So if you see the distribution of the data points, we understand whether it is low bias or high variance. This is the references we have taken from the textbook of Michel, pattern recognition classification by Richard Duda and Hart. Thank you.